23 million people live in Florida, and in May of 1981, the state showed everyone exactly what that means. A family in Winter Park heard their dog barking at a crack in the yard. 6 hours later, their house, several cars from a nearby dealership, and the town's public pool were gone, swallowed into a hole the length of a football field. That's simply Florida working exactly the way Florida works. There is no bedrock underneath Florida the way there is under nearly every other state on the map. There's a sponge, and every storm that rolls off the Gulf is quietly hollowing it out further. This is the real reason Florida looks nothing like anywhere else in America, and it starts with a seabed that never really left. Every other state you can name sits on a foundation of hard, ancient, crystalline rock, the same kind of bedrock that holds up mountains and resists a shovel. Florida doesn't have that. What Florida has instead is limestone, soft, porous, and chemically unstable in a way almost no other populated place on Earth has to live with. That single fact makes Florida, in the most literal geological sense, the opposite of every other state in the country. Soft rock instead of hard rock is why Florida has no real earthquakes, since there's no active fault line anywhere nearby to fracture and slip the way there is out west. The same softness is behind the 1,000+ freshwater springs that draw tourists by the millions, some of the highest concentration of major springs anywhere in the country. It's also why so much of the state sits barely above sea level, flat in a way almost nowhere else in America is flat. And every few years, that same soft rock is why a piece of ground somewhere in the state simply gives out beneath a house, a road, or a golf course with almost no warning at all. None of this is bad luck. It's the direct, physical consequence of building 23 million lives on top of rock that behaves less like stone and more like a very old, very slowly melting block of sugar. There's an old joke Floridians tell about their own state. The further north you go, the further south you actually get, culturally speaking, since the northern panhandle feels more like Georgia and the deep south of the state is where all the transplants land. But geologically, the joke runs the other way. Every mile of Florida, north to south, is sitting on some version of the same soft dissolving foundation. To understand the state at all, you first have to understand that it is, geologically speaking, the youngest and strangest ground in the country. To find where this rock actually comes from, you have to go back tens of millions of years, long before there was a Florida, a Gulf of Mexico coastline, or a single human being anywhere on the continent. For most of that stretch of time, the land that would become Florida sat entirely underwater, a shallow, warm, tropical sea, not unlike how the Bahamas look today. Picture that instead of a peninsula, just a bank of clear, warm, shallow water sitting on the edge of the continent with nothing above the surface at all. Billions of marine organisms lived and died in those waters. Corals, mollusks, single-celled algae with hard little shells, all building the same kind of calcium carbonate skeletons that make up modern coral reefs. Their remains piled up on the seafloor for millions of years, layer after layer, accumulating and slowly cementing together into thick beds of limestone, hundreds of feet deep in places. That process, slow accumulation and cementation of ancient sea life, is literally what the ground beneath Florida is made of. Saying Florida used to be ocean floor isn't a figure of speech. It really is ocean floor, one that happened to rise just high enough, just recently enough in geological terms, to break the surface and become a state people could live on. Drive almost anywhere in rural north central Florida, and you can still find that history sitting in plain sight, in yards and fields where the topsoil is thin. Ancient fossils, fossilized coral fragments, the mineralized remains of a tropical sea worked right into the dirt people mow their lawns on. Geologists studying the region today still use the modern Bahama banks as the closest living comparison, a shallow, sunlit platform where the exact same kind of limestone building is happening right now, just a few hundred miles away in real time. Stand on one of those banks today and you're essentially standing on a preview of what Florida looked like before it ever became Florida. That comparison is not a loose metaphor. It's the standard reference geologists reach for when they need to explain, to someone who has never thought about it, what a young carbonate platform actually looks like while it's still forming. The platform didn't just sit there and quietly rise either. Sea level itself has swung dramatically over the last few 100,000 years, mostly driven by ice ages locking up huge volumes of the planet's water in glaciers far to the north. Every time an ice age deepened, sea level dropped, and more of that limestone platform broke the surface for the first time. Every time the ice melted back, the ocean crept back in and covered parts of it again. Florida's modern shoreline, the one on every map today, only really settled into something close to its current shape within roughly the last 10 to 20,000 years, which on a planet that's 4.5 billion years old is close enough to yesterday that it barely counts as history. That's part of why this state feels geologically like it's still being decided. That alone would make Florida geologically unusual, but the platform sitting on top of all that limestone is only half the story, because underneath it, thousands of feet down, is something almost nobody expects. Getting to it takes real drilling. Researchers have to sink a core sample deep through the limestone, through layer after layer of compressed ancient seafloor, until the drill bit finally hits a completely different kind of rock. Dense, crystalline, and far older than anything above it. That deeper layer is known to researchers as the Suwannee Terrane. And when geologists finally examined it closely, they found something that didn't match anything else in North America. The way they figured this out is almost as interesting as what they found. Buried inside that deep rock are microscopic mineral grains called zircons. And zircons are unusually good at holding on to a reliable geological timestamp, locking in trace amounts of radioactive elements the moment they crystallize, elements that decay at a fixed known rate ever afterward. By measuring exactly how much of that decay had happened inside zircons, pulled from Florida's deep basement, researchers could read off both the age and the chemical fingerprint of the rock those crystals came from. Neither one matched the rest of the continent. Both matched rock from West Africa. The best current explanation, laid out in geological survey work and backed up by that zircon dating, is that this piece of crust was originally part of Gondwana, the ancient southern supercontinent that included Africa, and it was already welded onto the edge of North America hundreds of millions of years ago, long before the Atlantic Ocean ever existed. When Pangaea eventually broke apart and the continents drifted to where we find them today, this fragment of African affinity crust simply stayed put, attached to us instead of drifting back across the ocean with the rest of Africa. Florida's foundation, the rock far beneath the limestone you'd actually dig into in your own backyard, is quite literally a piece of Africa that never went home. It's worth sitting with how strange that actually is. Every other state east of the Mississippi sits on crust that has a continuous, traceable North American history going back further than almost anyone can casually picture. Florida's surface, the sand, the limestone, the beaches everyone associates with the state is genuinely North American and genuinely young. But scrape all the way down past that, and the rock holding the whole peninsula up came from somewhere else entirely, and simply never left once it arrived. Nothing else on the eastern half of the continent has quite that story. Researchers didn't stumble onto this by accident either. It took decades of oil and water well drilling logs, geophysical surveys, and eventually targeted deep basement coring before anyone could piece together just how far the African connection actually extended underneath the state. And refinements to that picture are still being published. Every few years, someone drills a little deeper or dates a slightly older sample, and the map of exactly where that borrowed crust starts and stops gets a little more precise. None of this shows up in a typical 4th grade Florida history unit, which tends to jump straight from swamp to statehood without ever mentioning that the state's actual foundation has a passport stamped somewhere in West Africa. It's the kind of fact that changes how you look at the ground the next time you're standing on it, whether that's a backyard in Ocala or a beach in Naples. If a discovery like that is exactly the kind of thing you want more of, this is a good moment to hit subscribe, because there's more of Florida's buried history still ahead, and this channel exists to keep digging it up. That deep, borrowed foundation also explains why Florida has essentially no earthquakes worth mentioning. States like California sit near the boundary of 2 tectonic plates that are actively grinding against each other, building up stress that eventually snaps. Florida sits in the middle of a plate, far from any active boundary, on a slab of crust that has been geologically quiet for an extremely long time. No grinding fault lines nearby means no meaningful earthquakes. It's one of the few genuine advantages of Florida's strange foundation. The limestone resting on top of it, though, is a different story entirely, and it's the part of this rock that 23 million residents actually have to live with every single day. Limestone has one specific vulnerability that almost no other common rock shares. It dissolves in ordinary rain. Rainwater picks up a small amount of carbon dioxide as it falls and moves through soil, turning it into a weak acid, the same basic chemistry that gives soda its fizz. That mildly acidic water doesn't just run off limestone the way it would off granite or basalt. It slowly eats into it, widening tiny cracks into channels and channels into caves. Geologists call this process karst, and Florida is one of the most heavily karst-shaped landscapes on the entire planet. Picture the ground beneath the state less like solid rock and more like a block of Swiss cheese that keeps getting more holes drilled into it, year after year, storm after storm, with no end in sight. That slow dissolving is exactly what gives Florida its most famous natural feature: its springs. Water percolating down through the limestone collects underground in the Floridan Aquifer, an enormous natural reservoir held inside the porous rock itself, essentially a hidden underground lake spread across most of the state. In more than 1,000 places, that aquifer breaks back out at the surface, feeding some of the clearest, most strikingly turquoise spring water anywhere in the country, cold and clean enough that Florida built an entire tourism industry around swimming in it. Florida has one of the highest concentrations of major so-called first magnitude springs found anywhere in the United States, more than any other state. Every single one of them exists because the same dissolving process that creates sinkholes also carves out the channels that let that ancient groundwater resurface. Even some of Florida's famously round, spring-fed lakes trace back to this same plumbing. Sinkholes that filled in with water so long ago that locals simply grew up calling them lakes and never thought to ask why they're shaped the way they are. Entire small-town economies in Florida run on this plumbing without most visitors ever realizing it. Roadside attractions and state parks built around a single spring vent that has been pushing the exact same volume of ancient filtered groundwater to the surface for longer than anyone alive has been keeping records. But dissolve enough limestone in the wrong place, and the ground eventually runs out of support. When an underground cavity finally grows too large to hold up the sand and soil above it, that material collapses downward all at once, and that's a sinkhole. Some open slowly, sagging gradually over months as the ground settles, what geologists call cover subsidence. Others let go all at once, a sudden cover collapse, with no warning beyond maybe a day or two of small cracking in a driveway or a wall. Drought makes both kinds more likely because dry ground loses the buoyant support water normally provides, and heavy pumping from the same aquifer for drinking water and irrigation speeds the process further. The counties in west central Florida, Hernando, Pasco, and Hillsborough see this often enough that the region has an actual nickname in the insurance industry: Sinkhole Alley. Despite how often this happens and how much it affects property values across the state, Florida has never funded much serious research relative to the scale of the problem. Some critics have suggested that's not an accident, that a state whose entire economy leans so heavily on real estate has little interest in publicizing exactly how unstable that real estate can be underneath the surface. Others point out it's simply hard to justify a bigger research budget for a hazard that statistically damages property far more often than it costs lives. Whether one of those explanations is closer to the truth or something else entirely is going on is a genuinely open question, and it belongs in the comments below as much as it belongs in any state legislature. Sometimes the collapse isn't a hole at all, but an entire lake vanishing. Just north of Tallahassee, one well-documented Florida lake has repeatedly drained away almost overnight through a natural sinkhole hidden in its own lake bed, dumping the lake's water straight down into the aquifer below before slowly refilling over the following months or years. It's happened more than once in recent decades. Nobody in Tallahassee treats it as a catastrophe anymore. It's simply understood locally as the same karst plumbing that feeds every spring in the state, working in reverse for a season before the lake quietly fills back in on its own. Not every sinkhole story ends that gently, though. In 2013, in the small community of Seffner, a man named Jeff Bush was asleep in his bedroom when the ground beneath his house gave way without warning. His brother in the next room heard the collapse and tried to reach him, but the floor was already gone. Jeff Bush was never recovered. It remains one of the only sinkhole deaths in Florida's recorded history, and the property was left as it was, a quiet, fenced memorial to how fast this ground can change. It's a sober reminder that the same geology behind a turquoise spring or a curious hole in a cow pasture can, in rare moments, be genuinely dangerous, and it deserves a moment of real weight before the story moves on, which brings everything back to Winter Park in May of 1981, because that single afternoon is really the whole story of Florida compressed into a few hours. The dissolving didn't start that week. It had been happening quietly underground for centuries, maybe longer. The same slow chemistry working through the same soft rock that once sat at the bottom of an ancient sea on top of a piece of crust that used to belong to Africa. The cavity beneath that yard had likely been hollowing out for years, patient and invisible, until finally, on one ordinary spring day, there simply wasn't enough limestone left to hold up a swimming pool, several cars from a nearby dealership, and a house. 350 feet across, 90 feet deep, gone in less than a day. A small tourist economy sprang up around the hole within days, vendors and souvenir stands appearing almost overnight, marking a disaster that hurt no one, because in the end, it was property, not people, that the ground swallowed. What happened in Winter Park wasn't a freak accident interrupting Florida's normal geology. It was that geology doing exactly what it has always quietly done, just finally loud enough and public enough for the rest of the country to notice. If this is the first time you've seen the full picture behind that famous 1981 photo, it's worth sharing with anyone who's ever lived in Florida and wondered why the ground here behaves the way it does. Florida still carries the marks of that day and thousands like it in ways that go well beyond one famous hole in the ground in Winter Park. State law now actually requires standard homeowners insurance to cover a total catastrophic ground collapse, though homeowners still need to buy a separate policy add-on to cover smaller, more ordinary sinkhole damage. A legal distinction that exists only because this state's ground behaves so differently from the other 49. It shows up in something even simpler too. Almost no house in Florida has a basement. not because nobody thought of it, but because a high water table, sandy soil, and rock riddled with hidden cavities were never going to safely hold one. None of this makes Florida some kind of disaster waiting to happen. It makes the state exactly what it has always been, geologically speaking, the only place in America still sitting on an open, ongoing conversation between rain and an ancient seabed, one that shaped every spring, every sinkhole, and every strange, low, waterlogged mile of the place 23 million people now call home. It isn't a flaw in the state's foundation. It is the foundation still being written one rainstorm at a time. If you grew up in Florida, or you've lived there long enough to have your own sinkhole story, or your own memory of that winter park photo, it's worth telling in the comments below.